Do you know that Hipparchus is considered to be the father of trigonometry? Yeah, how does that help us anyway? Like, who did I help? But at least now you know to direct your aggression at when next to encounter a difficult trigonometry problem. So yeah, you could guess I'll be talking about trigonometry in today's lesson. Trigonometry is simply the measurement of the sides and angles in a triangle. Yeah, simple. So let's talk about a triangle. A triangle is any shape bounded by 3 sides and have 3 angles. And then we classify triangles based on their sides and based on their angles. Based on sides, we have first the equilateral triangle. For an equilateral triangle, all the sides and all the angles are equal. From the word equal. And we have that each angle of an equilateral triangle is equal to 60 degrees. We came about 60 by saying, since we know the sum of angles in a triangle is 180, if I do 180 divided by 3 equal parts, I'll have that each of them will be what? 60 degrees. So that's for an equilateral triangle. Also, we have the isosceles triangle. For an isosceles triangle, isosceles mean equal legs. And if you're a human watching this video, you'd agree with me that you have 2 legs. So for an isosceles, it means that 2 sides are equal. Where you see the tribal marks, yeah, I call them tribal marks. It shows that those 2 sides are equal. The angle opposite them, this angle right here, opposing this first side, and this one, they are also equal. Okay, and then finally we have the scaling triangle. A scaling triangle, a very scalar kind of triangle, if you know what I mean. For a scaling triangle, the length of all sides and all angles are different. So that the classification based on sides. We also have based on angles. First, we have the acute angle triangle. In an acute angle triangle, one of the angle is less than 90. We also have the right angle triangle, which will be the more details in this lesson. For a right angle triangle, one angle is equal to 90. Where you see this small box, it shows where the angle 90 is positioned, where you have your right angle. So here's our right angle equal to 90. We also have that the acute angle of a right angle triangle are complementary. That is the sum up to 90 degrees. Of course, when you remove 90 from 180, they are left to battle out and share the remaining 90. Finally, we have the obtuse angle triangle. For an obtuse angle triangle, one of the angle is more than 90 but less than 180. The question though will not be, why is there no reflex triangle? I mean, you have your acute, you have your obtuse. Why is there no reflex? Alright, so that's at the lighter mode. Now that we've brushed up on our knowledge of triangles, yeah, let's proceed. Up next will be the naming ceremony of a rectangle triangle. Yes, I said naming ceremony. Okay, so remember, triangle has 3 sides. So does a right angle triangle have. So we'll be having the first side as the hypotenuse. The hypotenuse is the longest side in the right angle triangle, or you could say the side facing the angle 90, facing the right angle. We also have the opposite, which is the side facing the given angle. That's the opposite. And then finally we have the adjacent. The adjacent will be said to be the final side after you picked out your hypotenuse and opposite, or you could say, by my definition, that it is the side outside the right angle and the given angle. You will get to see what that means as we proceed. Okay, the first example, we're to label this triangle, we're to name it. The first name will be our hypotenuse facing the right angle triangle. You can see the arrow, that will be our hypotenuse. Then the opposite facing the given angle will be our opposite. Then the final side will be our what? Adjacent. And then from what I said, you could see that the adjacent side is what is housing this right angle, the base of the right angle and the base of the given angle. You can see they are both resting on the adjacent. That's why I said it houses both the right angle and the given angle. In case you want to get the adjacent first, you're fine. Alright, so the second one as well, we have our hypotenuse facing the right angle, opposite, and then our adjacent. We also have this one, we have our right angle we have our hypotenuse facing the right angle, we have our opposite facing the given angle, and our adjacent. If I'm to label this other angle alpha, considering alpha, the opposite then becomes this side and the adjacent goes right up here. This then tells us that the opposite and the adjacent could swap position depending on the angle you're considering at that particular point in time, but the hypotenuse remains constant. I hope you get this. Now you could pause the video at this point and solve this yourself. Okay, the solution, we have our arrows drawn, the hypotenuse, opposite and adjacent shown here for the second one as well. And then for the third one, let me know if you got the answers correctly in the comment section. All right, now that we can conveniently label the sides of a right angle triangle, let's go ahead to the main, what we're discussing today, the trigonometric ratios. We have 6 of them. We have the sine, we have the cosine, and we have the tangent. And then we have their inverse function, which is the cosec, the secant, and the cotangent. But for this video, we're discussing just sine, cosine, and tan to find the missing sides and angles in the triangle. Alright, so we also have what we call the SOH, the CAH, and the TOA. Very popular, you must have heard of them, you know. So SOH CAH TOA, yeah, it's a kind of mind trick that helps you to remember the formula for sine, cosine, and tangent. Yeah, so SOH stands for the S for sine theta, the O for opposite, and the H for hypotenuse. For the formula, we have the sine theta is equal to opposite over hypotenuse. For the CAH as well, we have that C is cos theta, A is adjacent, and then H is hypotenuse. Cos theta will then be equal to adjacent over hypotenuse. The reason why they are over is because, you know, we said trigonometric ratios, and ratios could mean division, right? So that's why we have that C equals tan theta, O equals opposite, and A equals adjacent. The formula would then be tan theta equals opposite over adjacent. Alright, next to be, how do I apply all this and finding the missing sides and the angles in the triangle? Like, how do I know which one to use? Trig problems now. Now we're to find the missing sides and the missing angles in this triangle. The first thing you do, or my own style of teaching this, and I feel it will be easier for you, will be to check for 2 things. First to be the given side, and the second will be the side you want to find. So what I mean, you were given 80 centimeter as your opposite. I believe by now you have no problem identifying the sides of a right angle triangle. Alright, so 80 centimeters are opposite. I'll write here. I'll write that my opposite now is equal to what? 80 centimeter. Then let's solve for our x first now. We have that our x is our hypotenuse. Hypotenuse is equal to x. Now you check the first 2 letters in what you've written. I have O and H, the first letter in both of them. That reminds us of SOH. And then SOH stands for what? It stands for the sine theta. Remember, is equal to opposite over hypotenuse. And of course, our theta, the given angle, is equal to what? 67 degrees. So solving and plugging in all our variables, we have the sine 67 degrees is equal to opposite now will be 80 centimeter over x. Sine 67, checking from your calculator, would be 0.9. So checking your 4-figure table to 2 decimal places, 80 over x. I could the next thing here would be that you cross multiply. Cross multiply means you multiply them across each other. Okay, so I'm having that 0.92 times x, that will be 0.92x equals 80 times 1 will be what? 80. Then I divide both sides by 0.92 by 0.92. You could plug this in your calculator, or if you have a computer brain like me, you could give the answer as 86.91, correct to 2 decimal places. All right, yeah, so that's for x. For our y, then we'll check again. Our y will be, again, I'll write my opposite is equal to 80 centimeter. Someone might want to ask that, why am I not using x? Since I've solved for x already, why am I not using x? The reason would be that just in case you made an error in solving for your x, your y won't be affected. In order to at least salvage one of the answers, so it's better that you use the value given in the question. That way you're safe. But then if you're so sure and confident in what you've done, you could go ahead and use x. It's very fine. So opposite is 80, and then our y now will be the adjacent. Our adjacent, we have y The theta still remains what? Still remains 67 degrees. Okay, I'm having OA as the first letters. OA. OA reminds me of what? TOA. And TOA stands for tan theta is equal to opposite over the adjacent. Alright, so I have the tan 67 degrees is equal to 80 over y. Tan 67 now from a calculator would be 2.36 equals 80 over y. Then you can put over 1 and then you cross multiply. That will be 2.36 times y. That will be 2.36 y equals 80 times 1 over what? 80. I then divide both sides by 2.36 over 2.36. Okay, then I have this cancel each other right here. I have the y is then equal to 33.96. That's the decimal places. That's our answer. If I'm sticking to the nearest whole number, x here will be equal to 87 centimeter, and then y here will be equal to 34 centimeters. So that's how you find the missing sides in your triangle. For the missing angle now, remember they are both complementary. The acute angles of right angle triangles are complementary. So to just find this one, I'll just say 90 minus 67, and that will be equal to 23 degrees. Alright, let's do a second one. For this one, we're to find P and Q and the missing angle. Again, I'll check for the given side, which is 29, and that's our adjacent. So I have that my adjacent is equal to 29 meters. And then finding, let's look for P first. P will be our opposite. Opposite equals P. Okay, theta then is equal to what? 45 degrees. Yeah. Now, taking out the first letters of the both of them, I have AO. AO reminds me of what? TOA. And TOA stands for tan theta is equal to opposite over adjacent. Now, at this point, maybe I say this. Do not be confused and say that because I'm having AO, then the formula should be adjacent over opposite. That's extremely wrong. The formula doesn't change. It's always opposite over adjacent for your tan theta, regardless of how you arrange the first letters. Okay, so I have the tan 45 degrees is equal to opposite will be P over 29 meter. Alright, tan 45 will give me 1 if you have an idea of your special angles very well. Then P will be equal P over 29. Then I put over 1 here and cross multiply. I have that P times 1 will be P equals 29 times 1, which is 29 meters as our P. You would notice that this is the same as our adjacent. Why could that be? Okay, I'll be waiting for your answers in the comment section. Alright, so that's our P. Let's find our Q. For our Q, adjacent remains 29 meter, and then our hypotenuse now is equal to Q. AH reminds us of what? CAH. And then CAH stands for cos theta is equal to adjacent over hypotenuse. Alright, theta remains 45. I have the cos 45 degree is equal to adjacent to be 29 over Q. Cos 45 again from our special angles is equal to 1 over root 2. That will be equal to 29 over Q. Cross multiplying, I have that 1 times Q will give me Q, and then 29 times root 2 will be 29 root 2. But that will be 41 meters to the nearest meter. Alright, so that's our P and Q. To find the missing angle here, remember they are complementary, so this will just be 90 minus 45, and that will give me 45 degrees. Yeah, this is the answer to our question, and that's the reason why they are both equal. That's the P and the adjacent side. It's because this is an isosceles right angle triangle. Two angles are equal, so definitely the two sides facing them will also be equal. Alright, so Give me the answer already. Alright, final example. But to find the angle now, the missing angle, still the same procedure. I'll check for the known sides. I have that my opposite is equal to 9 meter and my hypotenuse is equal to what? 15 meters. Okay, I have OH. OH reminds me of SO, and SO stands for sine theta equals opposite over hypotenuse. Alright, our theta is unknown, very big question mark. Yeah, we don't know it. So sine theta remains sine theta, nothing will change, equals 9 over 15. Let's divide this. 3 can go, that'll be 3 and 9. I have 3, and then I have 5 decimal, that'll be 0.6. We then have that sine theta is equal to 0.6. Now what do? I would divide both sides by sine, and that will give me that theta is equal to sine inverse, like sine raised to power minus 1, yeah, of 0.6. For this one, you could check your calculator by pressing the second function of sine to give you sine inverse of 0.6. My answer, or our answer, would then be 37 to the nearest degree. Answer 37. So times 37. To find this missing angle, what do I just do? I'd say 90 minus 37, and that will be equal to what? 53 degrees. Alright, so we could find this missing side. Let's call it D. We could find D by using Pythagoras theorem. You could use SOH CAH TOA as well to find D. Let me know your answer for D in the comment section. Alright, so yeah, we've come to the end of today's lesson. I do hope you understand. Please do ensure to subscribe, to like, to share, to comment. And for those of you that skip to the end, please go back now. Yes, you, I'm talking to you. Go back and watch. Alright, so that'll be all for today. Bye for now. See you in the next video. Bye.